All right, this is going to be a long one, and I apologize about that, but we're looking at surface area. Now, surface area is a lot of work. We're looking at, okay, we have these three-dimensional shapes. We spent some time saying, well, how do we figure out how much can we fit inside of the shape? Now we're going to look at, what if we want to make a box that looks like this shape? How much material would we need? How much cardboard would you need to make this hexagonal prism? And so we're going to be flattening things out. We're going to be saying, okay, we've got this cube. If we flatten it out, what would it look like? How much material would you need to make this icosahedron? And you can see one of those kind of hanging in my classroom. So we're going to be making these nets. So we call that a net. So say hi, Annette. Get it? Because it sounds like a girl's name. Okay, so we've got these nets. It's a flattened out two-dimensional version of this three-dimensional shape. And we're saying, well, how much material would you need to make it? Okay, to find the surface area, sadly there's not a fancy formula that we're going to use. Rather than doing that, we're going to flatten out the shape, and we're going to look at all the lateral faces. We're going to take the sum of all those lateral faces. So we're going to say, well, here's a cube, and we've got 1, 2, 3, 4, 5, 6 lateral faces. If we find the area of each of those lateral faces and add them all together, that's the surface area. So cylinder, we'll come back to this, but we get 3 faces that we'll add all together. A dodecahedron, we've got 12 of those pentagons. If we add the faces all together, we'd find the surface area. How much cardboard would you need to make that box? Okay, let's get right to it. So I've got a prism, a rectangular prism. If you think about a cereal box, and we're going to try and find the area of all those faces. So I'm going to attempt to draw a net. It's just such a funny joke. I had to keep going. There you go. I drew a net. So we're going to draw a net of this prism. If I start with, we'll go with the front here. So if this is the front of my rectangular prism, the rectangle is a 3 by 14 rectangle. So I've got that's close, 3 by 14 rectangle there. And okay, so there's the front. We've got it. Let's keep going around. I'm going to go clockwise around. So now we've got a side of the box here. I'm just going to call that a side, which is a 5 by 14 rectangle. So I'm going to keep going here, and I've got that's pretty close, a 5 by 14 rectangle. There we go. And if I went the other way, well, we'll just keep going around, I guess, clockwise. The back would be, back here, which here's a better three-dimensional picture of it. So there's the front, there's the side. If you go around to the other side, oh, there's the back. No, the back and the front, they're the exact same on a box. The front and the back are the same. Same thing with the two sides. The two sides are the exact same size. And so I can use that to help me draw this picture. The front and the back, so I've got the front, I've got the other side. Here's the back, 3 by 14. And the other side, so the other side would be over here, I guess. That'd be the other side. I'm going to put over here, but that would be the other side, 5 by 13, or excuse me, 5 by 14. Then we'd have the top and the bottom. So here's the top, and I guess we'll go with BO maybe for bottom. And so watch out for BO. We got the bottom, we got the back. There we go. And if you think about the three-dimensional figure, if you look at this here, we got the top and we got the bottom. Again, they're going to be the exact same size. And so for my net here that I'm drawing, I'm going to put the top up here, and I'll put the bottom down there. And the top and the bottom are going to be 3 by 5. And so we can see that with the bottom here, we'd have 5 by 3 by 5 bottom and top. Okay, so we've got our net. Now let's find the surface area. So if I start with the front and the back, we're going to have, okay, so surface area Surface area is going to be, let's see, the front is a rectangle. It's going to be 3 by 14. So 3 by 14. So I can find the area by doing 3 times 14. Now I could do the exact same thing for the back and do the front plus the back. However, I want to be at least a little bit creative here and save myself some work. Since the front and the back are the exact same, let's just do times 2. So base times height, 3 times 14, and since the front and the back are the exact same, we can just double it. All right, sides. So we've got a side is 5 by 14, 5 by 14. So I'm going to do 5 times 14. And again, since the two sides are the exact same, I'm just going to double it. So this is side and the other side. My S's are poor, but you get the idea. And then we've got the top and the bottom. So the top and the bottom are the exact same. And so again, I can do plus top, bottom. We'd have 3 times 5. 3 times 5. 3 times 5, base times height. And the top and the bottom are the same, so I can double it. That's it. That is not a pretty formula. It's just a whole bunch of stuff. But that's what surface area is. It's finding the sum of all the lateral faces. Now with the rectangular prism, we're lucky because 3 of the sides are doubled. So we only really have to find the area of 3 faces. Double them all, and then we can add them all together. So 3 times 14, 30, 42. Times 2, we got 84. 5 times 14 is going to give me 70. Times 2 is going to give me 140. 3 times 5 is 15. Times 2 is going to give me 30. If I add all of those together, I get, what, 170, 150, 254? Double check my mental math there, but I'm pretty sure 200, and you'll let me know, please, 254. Now, even though we're talking about 3-dimensional shapes, we are flattening it out into 2 dimensions. And so we're really just finding area. Area is square units. It's how many squares could we fit, because we're not looking at cubes on the inside. So 254 units squared would be the final answer. Give this one a try. It's very similar. Find the area of the front, double it to find the area of the back. Find the area of the top, double it to find the area of the bottom. Find the area of the side, double it to find the area of the other side. Add them all together, and you should get the right surface area. So again, pause it, try it on your own. I'm going to assume that you paused it. I'm going to assume you tried it on your own. The surface area for this ends up being 136 units squared. And so if you did not get 136, make sure that you watch the linked video or go below the video in the form, find this example, and give this one, or look at how to get the right answer of 136 square units. Triangular prism. Again, very similar idea. We're going to find the area of all the faces and add them all together. The problem, of course, is that very few of these faces are duplicates of each other, because the triangle, the 3 sides of the triangle, we've got, use this color, we've got a 5 here, we've got an 8 there, which really is this side here, 8, and then we've got 6 here. So all 3 sides are different, which means that the rectangles will be different. And if you flatten that triangular prism out, you'll see that we have a rectangle on the bottom. There's a rectangle on the bottom there. So the bottom rectangle is going to be 5 by 10. We've got a rectangle on the side here. There's a rectangle on the side, and that's going to be 8 by 10. And then we've got a rectangle on the other side, over here. And that rectangle, or parallelogram, it kind of looks like, but it's a rectangle, is going to be 6 by 10. So that's going to be a 6 by 10 rectangle. The triangles, luckily, the triangles are the exact same. And that will be true for any triangular prism, that this triangle on the front and this triangle on the back, they're the exact same size. And so we've got a triangle here, we've got a triangle there. Oops, sorry. We've got, because the triangle is attached to the 5 here, so we've got a triangle here, we've got a triangle there. And the height of that triangle, which we need to know, the height of that triangle is 4. So that is a 4, even if it doesn't really look like it, but it's a small space, so that's a 4. All right, let's find the area of all my faces. There are 5 faces total. If I look at the first blue one here, I've got 5 times 10, base times height. Okay, so that's a rectangle. Then I've got the purple one, and that's going to be 8 times 10. Again, another rectangle. Then I've got the orange rectangle, 6 times 10. Again, another rectangle. And last but not least, I've got my 2 triangles. 2 triangles. And so I can multiply it by 2. I can double it. Area of a triangle, base times height divided by 2. So the base of my triangle, 5. The height of my triangle is 4. So base times height divided by 2. It's going to be the area of that triangle. All 5 faces. Not pretty, not easy, but that's what we need to do. That's surface area. Surface area is the area of all the surfaces. 5 times 10 is 50. 8 times 10 is 80. 6 times 10 is 60. 5 times 4 divided by 2 is 10. Times 2 is 20. Now there is one shortcut that we could look at here. If you notice, all the rectangles have the exact same number in common, 10, which is the height of the prism. So if you can find the 3 sides of the triangle, 5, 6, and 8, if you can find the 3 sides of the triangle, you can just do 5 times 10, 8 times 10, and 6 times 10. You can just multiply the 3 sides of the triangle times the height of that prism. And then you still have to add on those triangles at the end, though. Keeping going, we should have, 210 units squared, I believe, for that one. 210 units squared. Triangular prisms are definitely trickier. Give this one a try. Find the area of all 3 rectangles that go around the outside. Find the area of the triangles and add them all together. All right, I'm assuming that you paused it. I'm assuming you tried this one on your own. So to find the surface area, we end up with 96 square units for this one. So if you didn't get the right answer, follow the link or look at the video on the bottom and watch how to get that answer. Last one here, cylinders. So we've got rectangular prisms, triangular prisms, and cylinders. So I've got my net that I've drawn. You can copy that down. And we're going to find the area of this cylinder. So the circles, let's look at the circles. The radius of that circle, 1, kind of looks like a kind of happy face. That one not quite so happy, he's angry. So you're happy on top and angry on the bottom. Find the area of the circle. Okay, pi r squared. We can do that. So the surface area is going to be pi, 3.14, times the radius squared. Both the circles are the same. Double it. There we go. Found the area of the circles. That's not so bad. Now we got the rectangle. I know how to find the area of a rectangle. Base times height. Height is going to be 10. Get that from there. The base. If you take your paper that you're holding and you curl it into a cylinder, the base of that rectangle, the base of your piece of paper, as it's a rectangle, when you curl it around into a circle, the base of the rectangle, this base right here, becomes this distance around the outside of the circle. And we call that distance the circumference. So the circumference of the circle is going to be pi 3.14 times the diameter. 2 pi times the diameter. So the base of my rectangle is the circumference. The base of my rectangle is pi times the diameter. The area of my rectangle then, area of my rectangle is going to be the circumference, 3.14 base times height. Again, we get the 3.14 times 2, is that's the base of the rectangle, that's the circumference of the circle, times the height, 10. So, okay, let's work through this. I'm going to start from the beginning here. 3.14 times 1 squared is 3.14, times 2 is 6.28, plus 3.14 times 2, 6.28 times 10, 62.8. And then if we add those together to get the final answer, we get 69, and it doesn't say to round, but we'll maybe round to the 10th place, 0.1 units squared. Now I will write down a formula for this one. This one has a slightly nicer formula than all the other ones. If you want to use this formula for the surface area of a cylinder, you'd have 2 circles, pi r squared, plus you'd have the rectangle, which is pi times the diameter times the height of the whole prism. So you can use that formula if you'd like. Give this one a try. Again, try it on your own. The radius of that circle is still 1, and it's 1 inch. So find the surface area of this cylinder. I'm assuming you paused. I'm assuming you tried it on your own. If you find the surface area, you end up with 94.2 square inches. If you didn't get that right, make sure that you follow the link. Make sure you watch the example video.